Students, good morning all of you. Today we are going to discuss about the experiment Young's modulus by non-uniform bending method. I hope you all know about the difference between uniform bending method and non-uniform bending method. So what is the difference between uniform bending method and non-uniform bending method, students? In uniform bending method, in the bending cross section of beam, radius of curvature remains same at all different points. In non-uniform bending method, in bending cross section of the beam, radius of curvature is different at different points. And one other difference is, in uniform bending method, load or mass is added at both the ends of the beam. In non-uniform bending method, load is added or load is fixed or it is suspended at the middle point of the beam. So this is one another difference, students. Note it down, students. In non-uniform bending method, the bending cross section of the beam looks like a boat, and at different points in the bending cross section of the beam, radius of curvature is different. So this is the main difference between uniform bending method and non-uniform bending method. In our today's class, we are going to see about do this experiment. Aim of this experiment is to determine Young's modulus of a given wooden beam by non-uniform bending method. Apparatus required: wooden scale, knife edges, traveling microscope, pin, screw gauge, vernier calipers and slotted weights. Formula: E is equal to mg L cube divided by 4bd cube y, and the unit is Newton per meter square. This is the apparatus of Young's modulus. There are two knife edges shown in the diagram, students. Over these two knife edges, a wooden scale is placed horizontally. There are slotted weight and a pin fixed at the midpoint of the Young's modulus apparatus or beam. And this is traveling microscope. It has a telescope with micro adjustment screw and vertical scale with micro adjustment screw. Main scale and vernier scale are there. This is main scale and there is a vernier scale, and this is horizontal scale of vernier microscope. Vernier and main scales are shown here. So in vernier scale there are 50 divisions, in main scale there are readings in centimeter scale, right? In horizontal direction also there are vernier scale and main scales available, and these are all weights with slotted weight hanger. This is how you have to focus the inverted image of a pin fixed at the midpoint of beam, right? So by adding masses given in the weight hanger, we can focus the inverted image of pin. So the tip of pin is slightly above cross section point. So what is cross section point? Horizontal and vertical line meeting point. So the pin is slightly above the cross section point. So you have to adjust the micro adjustment screw in vertical direction. See, after adjusting the screw, the pin will come to the cross section point. So you have to make the tip of the pin meet the cross section point. After making like this, we can take readings. We can take readings in vernier scale and main scale. So zero coincidence in vernier scale is a main scale reading, and out of 50 divisions in the vernier scale, any one division must coincide with your main scale. It is vernier scale coincidence. So like this, for each and every slotted weight or for each and every increase in weight, you have to take readings and you have to note it down in loading or under loading. For W plus 50, W plus 100, W plus 150, W plus 200 and W plus 250, we have to take readings and we have to note it down in the tabular column. Okay. So next, unloading. How to take readings in this unloading section? So while unloading a mass placed at the center of the beam, the tip of the pin will come very near to the cross section point, right? or it coincides with the cross section point. After making tip coincide with the cross section point, we have to take zero coincidence reading and as well as vernier scale reading in the vertical scale. In the vertical scale, you have to take main scale reading and as well as vernier scale reading. So the arrow mark, a small arrow mark is shown in the vernier scale. So this arrow mark coincidence is main scale reading, and out of 50 divisions in vernier scale, any one of the division must coincide with your main scale. It is called as main scale. It is vernier scale reading, right? Again, this is your next reading. On removal of the next mass, the tip of this pin will come down the cross section point. After adjusting the micro adjustment screw in the vertical scale, we can make the tip coincide with intersection point, right? Intersection point. After making the pin coincide with the intersection point, horizontal and vertical line meeting point, we can start taking readings in the vertical scale. So you have to take main scale reading and as well as vernier scale coincidence. Again I am telling, arrow mark shows your main scale reading. Out of 50 divisions in the vernier scale, any one division must coincide with your main scale reading. It is your vernier scale coincidence, right? So like this we have to take readings and note it down in the reverse way. The first reading is W plus 250. On removal of the next load, you have to write it down in the W plus 200 space, and next reading will come against W plus 150, then 100, then in 50, and finally you have to write it down in W. Next is screw gauge reading, students. So why screw gauge is used? Screw gauge is used to find out the thickness of the object. So in screw gauge you have to note it down two important readings. One is pitch scale reading and another one is head scale coincidence. So like this you can take any 5 readings, any 5 readings or any 5 place thicknesses, and you have to note it down the thickness values, or you have to note it down the pitch scale and the head scale coincidence values in the tabular column provided. So you have to at least take 5 pitch scale readings and 5 head scale coincidence values. At least you have to find out thickness of the beam at any 5 places. The given beam, so wooden beam thickness, you have to find out using the screw gauge instrument, right? At least you have to take 5 readings. With the 5 readings, finally you can find out thickness of the wooden beam. So pitch scale reading and head scale coincidence are important here. So using vernier caliper we can determine breadth of the beam. So using vernier caliper we can find out breadth of the beam. Just look at the instrument. You have to take 2 readings here. There is a 0 in vernier scale. 0 coincidence is main scale reading. Out of 50 divisions, any one division must coincide with your main scale reading. It is your vernier scale coincidence. See, 0 coincidence in the 0 in the vernier scale coincides with main scale. It is your main scale reading. And out of 50 divisions in the vernier scale, any one division coincides with your main scale. It is called as vernier scale coincidence. So like screw gauge readings, you can at least take 5 readings and note it down in the tabular column for vernier caliper. So using vernier caliper we can find out breadth of the beam at least 5 points, at least 5 points. So after noting down the readings you can find out breadth of the beam, right? So in the calculation part, these readings or these observations are very, very important. So we have to do this experiment for 100 grams. So m is equal to 100 into 10 power minus 3 kg, and breadth of the beam with the help of vernier caliper we can find out, and thickness of the beam using a screw gauge we can determine thickness. Acceleration due to gravity is 9.8 meter per second square, and mean value of L cube by Y by calculation we can find out. Finally, by knowing all these values we can determine Young's modulus of the material of the bar. And for wooden beam, this Young's modulus value, absolute value or actual value, exact value of this Young's modulus is 1.0 into 10 power 10 Newton per meter square. So for you people,
0.6 to 1.1 Newton per meter square. 0.6 to 1 into 1.1 into 10 power 10 Newton per meter square is accepted. So the final result of this experiment is Young's modulus of the material of the bar by non-uniform bending method. The result must be noted here. Thank you, students.